welcome back everybody. Thanks for stopping by and checking out our MPLS Layer 3 VPN video series. In this section, we're going to be taking a look at our next topic, which is going to be IS to IS as the PE to CE routing protocol. Now, this is not supported on iOS XR, unfortunately, so we're going to have to get CSR32 up and running, or CSR1 to R13. Whatever the case might be, that'll be the first step in the process that we need to do, is get the IS routing protocol working between on the customer to the PE side, and then do, like we did with RIP, do the mutual redistribution in order to propagate the routes. So let's go ahead and take a look at exactly how that works and go about getting that squared away. So I'm going to go and do this on CSR1 and get that squared away. So let's go ahead and get that configured real quick. So on CSR1, we're going to go and on CSR1, I'm going to go to global config, interface gig 3, VRF forwarding is going to be C1, IP address is going to be 101.1.13.1/24. We're going to no shut this guy. And then I'm going to go over to router 13. Bring this guy up to speed. The host name is going to be R13. Interface gig 000 or gig 00. IP address is going to be 101.1.13.13/24. No shut the port, and then interface loopback 0. IP address of 10.1.13.13/24. There we have it. So now what we get to go do is I'm going to create router ISIS, and I'll just say 13, and I'm going to type in the net on this guy is going to be 49.000.00013.00, and then I'm going to type in interface loopback 0 IP router ISIS 13 interface gig 0/0. There we have it. So now I'm going to go back over to CSR1, and I'm going to type in router ISIS, and I'll type in 1 here. Well, actually, I need to be cautious here, because if I, it's not actually the process number that makes a difference. It's the area ID, right? So I'm going to type in 1 here, and I'm going to type in the address family. Here is going to be IPv4, and then unicast. I need to specify the VRF of C1, and then underneath here I'm going to type in the net value is going to be 49.000, so that both CSR1 and R13 are in the same area. And then I'll type in interface gig 3 IP router ISIS1, and then once I do that, then I should be able to do show IP route VRF C1, and I should be able to begin seeing there it is. I was waiting for the loopback address to show up here, which is what I want. I want to be able to see on the provider edge router inside the VRF aware routing table. I want to be able to see the ISIS routes show up. So, and which is what I have. So now what I get to go do is do the exact same thing on 15 and CSR6. So on 15, I'm going to do the same thing. So router ISIS 15. I'll type in the net of 49.000.15.00, and then interface loopback 0 IP router ISIS 15 interface gig 0/0. There we go. And then CSR6, router ISIS 1, VRF C1, and then we're going to specify the net is going to be 49.6.00, and then we'll type in interface gig 3 IP router ISIS 1. Now, do show IP route VRF C1, and I should learn, and there we are. So now I'm glad that you caught that, because now what we have here is right here we had a, for the 10.1.15 route right here, we had a RIP learned route, right? Now for the 10.1.15 route, we now have an ISIS route. If I hit the up arrow, it'll be an ISIS route for good, because now this is what you'd want. And the reason why the ISIS took over for the RIP route is because the administrative distance of ISIS is 115 and the administrative distance for RIP is 120. So because we had this modification, it allows the ISIS route to take precedence over the RIP learned route, even though RIP is still technically running. So now we have that going. Now we need to redistribute from ISIS into BGP and from BGP into ISIS. So what I'm going to go do now is router ISIS 1. I'm going to type in VRFC1, type in redistribute BGP 100, and then right now we're level 1, so I'll just hit the enter key. We don't really need to do a whole lot more than that. Then router BGP 100, address family IPv4 VRFC1, redistribute ISIS, and then we'll type in 1 and do the exact same thing. So now on, because we're doing this on CSR6, if I go back to CSR1, do show BGP VPNv4 unicast all, I should now see the 10 dot, momentarily, I should begin to see the 10.1.15 route show up. Might take it a second or two for it to propagate. Let me see if CSR6 is propagating. So do show BGP VPNv4 unicast all. Okay, I'm not propagating it. So do show IP route VRFC1. I do have the route. Do show run section ISIS. So I am redistributing BGP 100, or see, it's level 2. So I actually have to go back here and type in redistribute ISIS 1, and I type in level 1, because the route that we have in the routing table is level 1. Level 1, and hit the enter key. So now that should be redistributed. Now it's being propagated, right? Now if I do show run section ISIS again, now it's level 1, level 2. That'll work. It gets the job done. I go back to CSR1, I hit the up arrow, and now the 10.1.15 route is being propagated. Now I go back over to CSR, or I'm sorry, router ISIS 1, VRFC1, redistribute BGP 100, and hit the enter key, and then router BGP 100, address family IPv4 VRFC1, redistribute ISIS, ISIS 1, and then level 1. So now if I do show BGP VPNv4 unicast all, I should now see the 10.1.13 being advertised into BGP, and now CSR6 should also see 10.1.13, which he does. Now the true test will be going to router 15, do show IP route. Do I see 10.1.13? And I do. And that is working out quite well. So now I see a bunch of routes coming through. I actually see the 10.1.13, 10.1.14. So you might say, okay, well, I thought we were only going to be propagating the 10.1.13 route. Well, we technically are. But because of the fact that CSR6 is using ISIS as the routing protocol between CSR6 and R15 as the PE2C routing protocol, what's happening on CSR6 is we're learning the 10.1.13 prefix and the 10.1.14 prefix through VPNv4. So because we're learning it through iBGP, through route reflection and the advertisement, we're learning those routes, and then we're then redistributing BGP into ISIS. Now if I take a look at the show IP route VRFC1, you'll see that I have the the two routes coming in. So one is coming from, this is RIP, right? Because we're still running RIP between XRV9 and R14. That's still a RIP route. And we're learning the 10113 through BGP. We can see the 200 here and the 20, because now it's ISIS between CSR1 and R13, because it's ISIS here. So let me paint this picture a little bit better than what I'm describing it. So the way that this is working is between here and here we have ISIS. Between here and here we have ISIS. And here we're using RIP. Let me go ahead and minimize the command line real quick. So that's where we're doing it. So we have RIP running here. So we have RIP learned routes here. Let me do this a little bit better. So we're learning RIP here. We're learning ISIS here. We're doing ISIS here. So what's happening is between here, let me go switch to a different color. Let me go to sky blue. Between here and here, we're doing IBGP, right? So the 13 route gets advertised into ISIS. That gets propagated via ISIS to CSR1. Router 14 is propagating 14 down to XRV9, and that's being learned on XRV9. Now, if we go to yellow, for example, we have a route reflector configuration set up between all these nodes, and like this, right? So all this information is getting propagated back and forth. So we have the route reflector config here, and the route reflector config here, so on and so forth. All that's happening. So whenever this route here gets advertised to the provider edge router, the provider edge router takes it out of ISIS, puts it into BGP, and then BGP propagates it via this connection right here over to the other provider edge router. The other provider edge router delivers it via iBGP, then redistributes BGP into ISIS, which then dumps the route into R15. So end to end, everything's working, and we don't have any BGP working at all here. BGP is completely out of the mix as a PE to C writing protocol. We're using two different IGPs, RIP here and ISIS here and here. So you can do a mixture of them as well. Now, was this intentional? It wasn't, but I'm glad it happened the way that it did, so you guys can see how this would have come into play. But because R15 is peering with CSR6 via ISIS, the route propagation is working as the way we'd expect it to. We're seeing multiple routes being learned via ISIS. That's the beauty of MPLS Layer 3 VPN. We can do it multiple ways if we want to. And that really, ladies and gentlemen, is what's happening here. So that's pretty much it for the breakdown and what you guys need to know. Let's go ahead and do some actual trace routes to verify connectivity. Let's go ahead and do that real quick. Let me go ahead and go to CSR15, or I should say R15. Let's do a trace route to 10.1.13.13, sourcing from loopback 0 numerically. We should have reachability there, which we do. And we should do 14.14. And uh-oh. Do we have a problem? We might. So do we troubleshoot this? Well, yes and no. So let's go take a look at this. Let's go back to the routing table. Let's do a show IP route. Oh, 14's still there. Why is 14 showing up? Let's take a look. So this is one of those times where verification exposes a problem. So let's reverse the workflow here. Let's take a look at 15. Now we have to jump up to CSR6. Let's jump out of global config and do a show BGP VPN-v4 unicast all. We're learning 14 via 9. So we're doing that. And we learned this prefix from both 10 and 4. We have reachability. So let's go to XRV9 and let's take a look at this. Let's do a show BGP VPN v4 unicast VRF C1. And I am learning the prefixes. I'm learning 13, I'm learning 15. So all of that looks pretty good, right? So I'm learning that, and then I go, let me take a deeper look here from 15, see what's up with that, because that seemed to be the one that was giving us a hard time. And where we're learning the routes, everything looks pretty good. So we have a label value associated to it. Label 44, label 44, which is what we would expect to see. So then we go down to R14, show IP route. Oh, what am I not learning? I'm not learning the 15 route. So XRV9 is learning it, right? Let's do a show route VRF C1. I'm learning 1015, but for whatever reason, router 14 is not receiving the route, right? I'm getting 10.615, but I'm not getting the actual loop back. So let's do a show IP RIP database and see what we're learning. We're only learning, we have the auto summaries enabled, so let's do a show run section RIP real quick. See if it's something that we overlooked in a previous config. No auto summary, so we're learning the 10net. So we're learning that, but why are we not learning the other route? Why are we not learning? So right now the problem we have is on XRV9, we're learning the route, right? We're learning 14 via RIP, we're learning 13 and 15 via BGP, but for whatever reason we're not taking those routes and taking them out of BGP and injecting them into RIP. Let's go take a look at that. Show run VRF. So we are importing all of those route target values. We're importing 1, 6, and 32. All of that looks right. So why are we not learning the routes? So this is actually a curious case because now we're not, let's take a look at the RIP config. Show RIP VRF C1 database. So we're learning the route, right? We're learning we've learned 10.1.14, but we're auto summary. So let's take a look at the config. Show run router RIP. So let me go up to global config and maybe let's take a look at the config. No auto summary. Let's type in no auto summary and see if that has an effect. Let's go ahead and commit that config. So now we jump out of global config. Let's do a show. Maybe that'll help, maybe not. Let's take a look at 14 again, because normally that would help. Doesn't look like it's helped. Show IP route. Yeah, see, it's not helping. We're not learning those routes in. So let's take a look at why we're not learning those routes. And this can be a little tricky to troubleshoot too, because sometimes it can be more than something. But we're learning the 10.6.15 route. We're not redistributing something correctly. So show run router RIP. We're redistributing BGP 100. Show run router BGP. We're not doing anything crazy. Let's change this up a little bit. Let's do a show router RIP VRF C1. Redistribute BGP 100. And normally I add a route policy to this. So route-policy. And I'm just going to come in here and say RPL RIP and I'm going to go route dash policy RPL rip. I'm going to say set the rip dash metric to be, and I'll say 2. Normally, this is what I normally would do. Show config. And then I go ahead and I commit this. And see if that helps. Ah, that's better. So I see I now have a rip metric to associate to it, right? Now if I do a show route vrfc1, now I see those routes are still in the routing table. I go over to R14, I look in the RIP database. Now I see the routes showing up in the routing table or in the RIB. Now they're there. So the problem was when I was redistributing BGP into RIP, I wasn't associating a metric with them. So basically RIP was like, well, I don't know how to calculate those routes. I don't know what to do with them. You would see something very similar in EIGRP, or if you didn't include the EIGRP metric with the redistribution, EIGRP has no way of calculating what's going on. Now, I didn't originally do this in the RIP video, and I'll make sure to edit that aspect in to add the RIP, the RPL configuration. But in most cases, you're okay without doing this. Depends on the scenario, but it's a best practice to use the RPL, the RIP metric capability whenever you're doing this config so that you don't have a problem. But let's go ahead and double check our config. Let's see if that helped. So if I do the trace route again, I get all the way across now. And why does it work now and why did it not work earlier? Well, the answer is actually really simple. Before, the remote end, R14, had no idea how to route the traffic back. So there has to be an end-to-end connectivity in order for the trace routes to work. Because when you get to the destination needs to know how to get back to the source. It's no different than if you get in your car and you drive to the store. You have to know how to get there and you have to know how to get back as well. So routing is bidirectional in that case. So that's one of those cases where you have to understand how the routing process comes into play. And this was a pretty good example of how that would come into play. So with that being said, ladies and gentlemen, that is pretty much it for this video in terms of how everything comes together. Until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.